Hi, I'm Raina Fitzgerald, and in this lesson we're going to be solving systems of linear equations with the addition method. Here's our first example. Now, what we want to do is to use the addition method, we have to transform our equations into standard form. So let's go ahead and do that, and we'll transform the first. And if we multiply everything by a 2, we end up with 2y equals x plus 3. So I've multiplied the y by a 2. 1/2 times 2 is 1, and 3/2 times 2 is 3. Now we're not quite done. We want this in standard form. So I have to move the x to the other side. So in standard form, so I would have negative x, so I add a negative x to both sides, negative x plus 2y is equal to 3. Now standard form is of the form a times x plus b times y equals c. There's one stipulation to standard form, however. A must be positive. So I need to multiply everything here by a negative, and that will give me x plus a negative 2y is equal to a negative 3. Okay, now let's transform our next equation into standard form. To do this, we have to add a positive 3x to both sides. When we do that, we end up with 3x plus y is equal to 5. Great. We've just transformed both of our equations into standard form. So now they're set up so that we can solve using addition. To solve using addition, let's set these back up so that they are written as a system of equations. Our first equation is x plus a negative 2y is equal to a negative 3. Our second equation is 3x plus y is equal to 5. So here's our system of equations, and we are ready to start to solve them using addition. When we use addition, what we're going to do is we're going to add our x values, and if we added them here, 1x plus 3x would give us a 4x. We're going to add our y values, and if we add our y values here, negative 2y and positive y gives us a negative y. And then we're going to add our constants. Negative 3 and 5 gives us a 2, and come up with another equation. But the problem here is, well, we don't want to add them right away. While we're adding, we want to eliminate either the x or the y. Well, if I add these two together, I'm not going to eliminate an x, and I'm not going to eliminate a y here. So what I need to do is I need to change one of these equations by multiplying one of them by some value. Now I notice that if I multiply the bottom equation by a 2, my y will become a positive 2y. And if I add a negative 2y and a positive 2y, I get a 0, and I'll eliminate y. So that's what I want to do. I'm going to write a little note here reminding myself that I took the second equation and multiplied it all the way across by a 2. So let's rewrite our top equation. Our top equation for line 1 is x plus a negative 2y is equal to a negative 3. That's our first equation. Now we're going to write the second equation, but remember, we're multiplying every term by a 2. So our first term, 3x times 2 is 6x, plus our next term is y. Y times 2 is 2y. And there we can see the elimination that will occur when we add the negative 2y and the positive 2y. And now we have a 5, and 5 times 2 is 10. Okay, this is the part where the addition comes in. So I'm going to put a line right here, and we're basically going to add, with a little plus sign, we're going to add the x's, the y values, or the x terms together, the y terms together, and then the constants. If we add the two x terms together, 1x plus 6x is 7x. Now we're going to add the two y terms. A negative 2y and a positive 2y is 0. And now we're going to add the negative 3 and the 7, and we get a 7. And this gives us on the left-hand side 7x, and on the right-hand side a 7. Now we're solving for x, so I'm going to multiply both sides by the reciprocal of 7, which is 1/7. And what happens is the 7 and the 1/7 cancel out, giving me x is equal to 7 times 1/7, or 7 over 7, which is 1. So I've just found my x value, but I'm not finished yet because I need to now find my y value. I want you to notice that we've used both equations once. Here's where we used our first equation, and here's where we use our second. There's the first equation, there's the second. Once we've used both equations once, we can now grab any equation we want and substitute our x value into it. Let's use the second equation because it has no fractions. So the second equation is y is equal to a negative 3x plus 5. And what we want to do here is we want to take this value for x that we just found and plug it into the original equation. When we do this, we have y is equal to a negative 3 times, not x, but 1, because we're replacing x with a 1, plus 5. Or y is equal to a negative 3 times 1 is a negative 3, plus 5. And finally, y is equal to negative 3 plus 5, which is 2. So here we have y is equal to 2. So our final solution to this problem is the ordered pair when x is 1, y is 2. Let's put a box around this, and here we have it. We've just solved this system of linear equations using the addition method, and there's our solution, the ordered pair 1, 2. This means that these two lines intersect at the point 1, 2. Here we have another system of linear equations, and what we want to do here is we want to transform this into two equations in, again, standard form. So we're going to take our first equation and multiply all the way across by 4 to get rid of the fraction, and we end up with 4y is equal to x plus 4. Now, we want the x on the left-hand side, so if we add a negative x to both sides, we get a negative x plus 4y is equal to 4. Now remember, in standard form, where we have a times x plus b times y is equal to c, a must always be positive. This means that we must multiply everything all the way across by a negative 1. This gives us a positive x, because a negative times a negative is a positive, plus a negative 1 times 4 is a negative 4y, is equal to a negative 1 times 4 again is a negative 4. So here's our first linear equation in standard form. So let's put a little underline under that. That's our first equation in standard form. Of course, we need it in standard form to do the addition. So now let's take our next equation, and again, we're going to multiply this equation all the way across by 4 to get rid of the fraction, and we have 4y is equal to x minus 4. Now again, let's add a negative x to both sides, and we get a negative x plus 4y is equal to a negative 4. We're almost in standard form. Remember, standard form is a times x plus b times y equals c. But a must be positive. So we're going to multiply everything by a negative, which gives us a positive x plus a negative 4y is equal to a positive 4. And let's underline this. This is our final equation for our second equation in standard form. Okay, let's go ahead and stack these equations one on top of the other. Here's our first equation right here, which is x plus a negative 4y is equal to a negative 4. And our second equation, which comes from here, we'll write that one down, that is x plus a negative 4y is equal to a positive 4. Here's our system of equations. Now if we add these up, we want to eliminate either the x or the y. And right now if we add them up, we're not going to eliminate either x or y, because x plus x is 2x, and a negative 4y plus a negative 4y is a negative 8y. So we're going to have to change them up a little bit and rewrite them. And let's go ahead and rewrite our first equation as x plus a negative 4y is equal to a negative 4. And our second equation, let's multiply it by a negative 1 all the way across. So we end up with a negative x plus a positive 4y is equal to a negative 4. All right, now we can add these two up. And if we add up a positive x and a negative x, we get a 0. Plus, when we add a negative 4x and a positive 4x, again we get a 0. And then when we add a negative 4 and a negative 4, we get a negative 8. So simplifying both sides, we have 0 is equal to negative 8. Well, this is not a true statement. This statement is false. If we end up with a false statement when we're solving a system of linear equations, we can be certain that what we have is no solution. This means that these lines never touch. Now you may have already noticed that right at the beginning when you first looked at the lines, because they have the same slope. Lines with the same slope are parallel, which means that they never touch. So the solution here using the addition method tells us that there's no solution. Here's our last example of a system of linear equations, and we're going to solve using the addition method. So the first thing we want to do here at the top is that we want to transform these into standard form. So we need to get rid of the fraction, so we're going to multiply everything by a 3, which gives us a 3y plus 2x, a 3y equals 2x minus, I'm multiplying everything by 3, a 6. Okay, because it's 3 times y is 3y, 3 times 2/3 x is 2x, and 3 times a negative 2 is a negative 6. We're almost there. We must bring the x to the other side, which means we need to add a negative 2x to both sides. So we end up with a negative 2x plus a 3y is equal to a negative 6. Well, we almost have it in standard form of ax plus by equals c, except our a value is negative, and it's not allowed to be negative, so we have to multiply everything all the way across by a negative sign, giving us 2x plus a negative 3y equals 6. So let's put a line under this. This is standard form, which is ax plus by equals c. All right, let's turn our next equation into standard form by multiplying first everything by 6 to get rid of the fraction. We end up with 6y is equal to 4x plus negative 2 times 6 is a negative 12. Now, we want to bring the 4x to the left by adding a negative 4x to both sides. And we end up with a negative 4x plus 6y is equal to a negative 12. Again, here our a value is negative and it has to be positive. So we're going to multiply everything by a negative and we get positive 4x plus a negative 6y is equal to a positive 12. I'm going to put an underline under this because this is in standard form, ax plus by equals c. All right, now we're ready to stack these two as a system of linear equations. Our first equation is 2x plus a negative 3y is equal to 6. And our second equation is 4x plus a negative 6y is equal to 12. And I'm going to put a brace on the left-hand side because this is a system of equations. Now, if we add these together, we're not going to eliminate 2 or y, so we're going to have to do something here. So what I'm going to do here is I'm going to multiply the top equation by a negative 2. So that's going to give me a negative 4x plus a positive 6y is equal to a negative 12. Now we're going to leave the bottom equation alone. It's a positive 4x plus a negative 6y is equal to a positive 12. And here we're going to use the addition and add these together. A negative 4x and a positive 4x is 0. A positive 6y and a negative 6y is also 0. And a positive 12 and a negative 12 is also 0. So the left-hand side simplifies to 0. The right-hand side is also 0. So what we have here is a true statement. So we've lost our x, we've lost our y, they're gone. We have nothing left except our statement, and our statement is true. Well, if our statement is true, it means no matter what value we plug in for x, there will be a corresponding value for y, such that the ordered xy pair that you get will work for both equations. So the solution to this equation is the line itself. And you may remember from solving this in an earlier lesson that these two lines are actually the same line. So you could just write the equation for either one of these lines, and I'm taking the top line, y is equal to 2/3 x minus 2. That line represents, or this equation represents both of these lines, and either one of these lines, because they're the same, gives us the solution to this system of two linear equations.